but today is just showing you the off-the-shelf HVAC controller, just so you can see what our web interfaces look like and see what it currently does.
It sounds good. I'll just pull the camera around and show you the box that we've got set up for this. Let's see if we can coordinate this with my webcam well enough. So you can see the HVAC controller is sort of right here. It's got LCD interface on the front, a few four buttons to sort of control the LCD, and a comfort mode button, basically, so we can have a technician just go in and punch that if we needed to basically rein it into a more reasonable sort of temperature for humans working rather than anything out in the field. Sort of on the inside of this, we'll see that we've got basically a board. It's going to have some interfaces here for HVAC connections, some interfaces as well for LAN connectivity to a 66 block, and optionally, this HVAC controller supports 4 HVACs plus another 2 HVACs through a top board extension here. So there's a lot of sort of connectivity that we've got, bringing this out to sort of sensors, LAN connectivity, USB connectivity. This guy's got 1 serial port on it, can designate normally open or normally closed for any of these relays as well.
And the board's on the door because this was originally developed for cell sites and large-scale deployments, and the idea was it's easier to swap in a spare if you just undo those 2 hinges and you can reattach it. But it doesn't really have much impact other than when it's open. But it ends up, the cabinet, we actually deepened it a little bit at the request of one of the original clients, so it can be used to store a user manual, a spare. I think we had excess sensor cable that they wanted to store in there, so it is a bit of a cabinet, but that tends not to matter when it's closed.
Yeah, and you'll see through that front panel, rather than give you a sort of far view of me punching some buttons and not having some clear visibility on the LCD screen, you could do sort of basic configuration and turn-ups, basic testing straight from that front panel, so you can eliminate the need for having something like a web interface for when a technician is installing it. That was something that was developed for the original client for that as well. So they didn't necessarily want their technicians getting around there and mucking with other settings. They just wanted 1 set of default settings that all of these guys would ship out with, and basically somebody to say there are 2 HVACs on this site or there are 4 HVACs on this site.
We don't see much use for that for most clients because they're not fighting their technicians about, well, make sure they set the heating and cooling window at these settings. So that most people just use the master password instead of the lesser password. Okay, so when you log into the HVAC controller, this is basically the web interface that you see. Most of our units are going to sort of have 3 main areas that this web interface is going to cover. There's this blue area for monitoring kind of functionality, so that's what you would get into if you wanted to just see what's going on the unit. There's a provisioning functionality. This provisioning is for doing deeper kinds of configurations, turning on or adjusting different kinds of edit and such, or editing sensor thresholds or basically temperature ranges from there. This reboot section is going to, on this unit, it's just reboot. On some units, it's going to have a device access section that maintains some other functionality as well. So we'll basically just take a look at this. We'll start at the this provisioning monitor section. So this monitor section, you can actually see that there's this LCD simulation. You can see exactly what's on the front panel if you're not in front of it, if that's of interest to you. Otherwise, you'll be able to see some of the configuration that's currently in this unit. So what I did yesterday before I took off for the day was I just came in through the front panel. I think it was probably about 15 button presses or so. I turned up this unit and configured
configured 2 HVAC units that could be connected to it, and a number of D-wire sensors as well. So we've got these, I don't know if you can you still see me in the screen, Andrew, or no?
Yeah, we can see you.
Okay. So these D-wire sensors are basically daisy chainable units. You'll be able to daisy chain a number of temp, humidity, or temperature sensors out from the HVAC controller just to get basic environmentals of the surrounding area. And then the HVAC controller will basically calculate based on those D-wire sensors what the average ambient temperature is and see if it's time to run or not. So we can see right here, there's a threshold for cooling, a threshold, or right now the average temperature is 77.1 Fahrenheit. This high temperature is 88 Fahrenheit. So the idea here is with this cooling mode, if this 77.1 ever drifted above 88, the HVACs kick on and will cool down to 74 Fahrenheit where they'll kick off again. So right now we're not running because we're sort of in this comfortable zone above low but below highs that we're kind of going to drift in between. And similarly for the heating mode, if it ever dropped below 45 degrees Fahrenheit, we're going to kick on the heat up to 50 degrees Fahrenheit and then kick that heat back off again. So that's sort of what's going on this page. You can see that we can have up to 6 HVACs configured on this unit. Currently only 2 are configured here. We've got an HVAC 1, HVAC 2. Currently, HVAC 1 is in the lag role and HVAC 2 is in the lead role, and that's sort of going to cycle through to distribute load between your different HVAC controllers. And that's on a sort of user configurable time as well. You can configure, do they shift daily, do they shift weekly, do they shift at some other time between that. We can also have vent sensor monitoring, and that vent sensor is basically going to be something that we could configure in order to determine if an HVAC specific unit is failing relative to the other HVAC units as well. And I could go into sort of more depth or answer questions as you need from there. Alarms is going to basically give us some feedback from other kinds of inputs that are more discrete in nature. So on the 66 block, that we ship out is going to have sort of this front panel that has labeled all of the contacts that we'll need to sort of maintain here. HVAC 1 failing, HVAC 2 failing, HVAC 3 failing. So those are all feedback kinds of things from the HVAC unit itself. So if the HVAC 1 fails to run, it's going to throw an alarm here. It's going to not try to start up that unit at all. It's basically just going to exclude it from the lead lag sort of configuration.
And some of these functions will stay the same. Like I know, Brian, you were talking about how the bar devices, the controller doesn't know when they fail. So critically, those fail at discrete should remain the same, but they are really general purpose in the firmware. I mean, we've written some things that I estimate we'll be customizing for you to like, we won't need 3, 4, 5, 6 for these if we're just doing 2. So that frees those up to be other kinds of things, could be door or motion or whatever we want as we replace some of that M5 functionality.
Kind of listed here are the defaults, as Andrew said, and we may do customizing on that as well. There's no typical need for any of these guys to be here, and if we know that we're going to be looking at a unit that's specifically only going to support a maximum of 2 HVAC units, then that's going to basically free up this 336 for other uses as well. Also, if we're not intending to use a discrete humidity sensor, probably going to use a discrete smoke detector at some point, on hydrogen sensors, whether or not we've got a generator running on site as well, are useful things that were needed by previous clients but may not be needed in your specific scenario. Beyond that, there's another tab for system alarms. This is just internal information about how the HVAC system is doing. So there can be a number of notifications, and we've got basically listings here for if one of those notifications tried to get sent out, but for whatever reason failed. Possibly an email server unable to be reached, or S&P manager unable to be reached, or something along those lines.
Oh, I did have one question on the lag and lead.
Yeah.
So if it gets over a certain temperature, I want to make sure, will it run both units?
Yeah, that's the idea. What we're trying to do here basically is once we pass the high threshold, I don't remember exactly how this was implemented in code. I'll have to like review it for you if you want the specifics here. But the idea is we'll rise above that high threshold, kick the lead unit on, and if the lead unit doesn't make adequate progress towards the low threshold, which is this is comfortable, it's time to shut off. If we don't make adequate progress with just the lead unit, it'll kick the lag unit on as well. And in a setup with 6 HVACs, it could theoretically run all 6 of those HVACs, basically triggering the lead and then looping in additional lag units as we detect that there's not enough progress being made towards the low threshold.
Hey, Jesse, go ahead and go to the green provisioning. Let's look at that setting real quick for the HVAC controller. Yeah. So you can see here the lag call on HVAC system timers, the 6th one. Yeah. That's a 5-minute keep out, because we learned lots of things, obviously, building this thing originally. And one of those things was you didn't want to immediately go to lag, just because the heat had some momentum. The lead unit was sort of revving up and be starting to do its cooling job. So what we do is we give it this amount of minutes. You can ratchet it down to just 1 if you want, but that's the time where it's not going to lag immediately. And then I think the original version of the code, Jesse, was if it didn't rise above 88, like as long as it got back into the window, then it was going to never call the lag, which was a problem. We had that one in Bakersfield freeze over. We put it up the first night, and you get to these weird equilibrium points where you're able to cool it down. It keeps it below 88, but it's like it hung at 84, and it never gets down to 74. So that's why, like Jesse said, we had to change it to kind of a momentum factor to say if we're not making headway in a little bit, and it's past the 1 minute or 5 minute or whatever setting you have there, then after that number of minutes, it's eligible to do the lag. And yes, lag, but we're only talking about 2 units here.
Yeah, and we'll add extra visibility into that as well. I think if we get into that no momentum detected state, it generates one of those system alarms and can generate a notification out. So if we get into a spot where HVACs are on and we feel like the HVACs aren't making enough progress towards the endpoint on that configuration, we can basically notify out, hey, you've got HVACs running, but it doesn't look like we're going to be able to complete our job with the horsepower that we've got running right now.
Yeah, because our windows are a lot tighter than this. Like we don't let our HUDs get over 80. So
yeah, you can certainly set it.
That's all configurable, it looks like. So.
Yeah, I mean, there's nothing keeping us from making this 75 or something along those lines. Something that's a little bit tighter in there. Yeah, so basically, as Andrew sort of keyed us over to this provisioning side, provisioning is where you would make a lot of those configuration kinds of changes. And you can see that there's a number of different things here. You can have your HVAC system set the cool only, heat only, automatically determine which one we should be doing based off of these thresholds that we're setting here. A lot of this is automatically configured when you key up the basically temperature sensors and such, and you do the configuration through the front panel. But some of this you might want to come in and tweak. This is basically the defaults that we would get on a fresh configuration. We could see here, number of HVAC units is set to 2. HVAC operational limit. I know that there was one client that had 6 HVACs, but they only wanted at most 3 running at any one time. So the HVAC operational limit was a feature to allow us to have like up to 6 HVACs in a ring, but prevents like that scenario where we have all 6 of them running at the same time. So HVAC system timers, direct air cooling. I know that we had a DAC feature on something, but as I said, I wasn't aware of the development of that at that time. So so I know that we've got that. We've got support for a generator as well, and having a generator basically being tied into the system. These ambient sensors are going to sort of collect the indoor temperature. We can have ambient sensors tied to outdoor temperature as well. These vent sensors are sort of designed to be sensors that can be used to monitor basically the output off of an HVAC directly. So if we have an HVAC unit that we trigger this on at 80, but we notice that the HVAC's vents aren't ever getting to 80 degrees, then that's a clear failure of that HVAC unit itself. So that's kind of what this is used for. I know that there's some support for airflow as well. I know we can't daisy chain a ton of the temp airflow sensors because of they draw a little bit more current because the sensors themselves have a small pick on them. But those can be used as well for monitoring multiple vents, and if it's blowing as much air as we're expecting it to.
Well, the vent temp sensors, that would be a big bonus for us, because that's something that does happen. We have one that's barely cooling and we don't know until someone gets there. So
got it. And I mean, those would just be additional D-wire sensors. So you might have an additional sort of a leg of D-wire sensors going out. You pop one of those temperature sensors inside of your vents. I don't want to sort of duplicate up with these, but you would see in this drop down, you could select any of the other configured sensors. And
so can you put the ambient temp sensor, is that the sensor that the controller is running the ACs off of?
Yeah, so these 4 ambient temperature sensors are basically spread throughout the room. So you can see that these 4 indoor ambient temperatures, and what we do is we basically just take the mean of those 4 sensors as the average room temperature. So 76.3.
Yeah, that'll be good. We've got a couple big buildings where one side is 80 degrees and the other side 60. You know.
Wow. Okay.
Just because of how.
Yeah.
So we end up having to turn one unit way down.
The way we're currently handling the string for that goes into that average. And if I remember right, Jesse, I think it triggers on an OR, meaning it's very sensitive. So if any one of the zones is above the high, it's going to kick on, and then it evaluates how it should lead and lag based on the average of all of them. So it's kind of a middle ground, but then it doesn't shut down till they're all happy, till they're all back below the low. So that's kind of the way we wrote it originally. If we need to tweak that, obviously that's not the most complex section of code. That's pretty easy to adjust. I could foresee that being a set of 3 drop downs. Like, how do you want to trigger, or and, or average? How do you want to continue, or and, or average? But, yeah, okay.
Yeah, I mean, that should be a fairly simple thing to implement there.
The default should probably be average all the way across, just so people at the beginning don't have that additional overhead of why isn't it doing things the way I expect.
Beyond that, there's a number of other configurations that are here as well. You can give your own descriptions. You could call out to your to notifications as well. Some of these descriptions as well will have a slight qualifier on them. It looks like these have been provisioned with qualification times at the beginning. And the qualification here is basically a way to debounce and keep us from seeing any kind of noise on an alarm line. So if something blips high and blips low, and this happens occasionally, but we don't but we don't need to actually take action on it until it's been standing there for, in this case, 3 seconds, or in this case, 15 minutes, then this qualification time is basically a way to delay alarm input kind of information. That's on alarms. We have controls as well. We can see all these controls have their auto descriptions populated, and some of them are going to have some sort of derived alarm logic. All of this was auto populated in here as well, but it's basically it boils down to sort of a Boolean logic kind of evaluation of different alarm points that are on the unit to determine when these controls should be triggered on or triggered off.
You want to pop open the display map, Jesse? So this is so we look at, oh, I'm sorry, I meant on that screen because we can see the equations too.
Yeah, I'll get back to that.
Yeah, it actually has one right there. You guys put that link like everywhere, but there you go.
Yeah, well, it's useful everywhere. I just forget that it's everywhere sometimes.
So Brian, it's a little bit interesting, our syntax, but you can see it starts with an O underscore OR. That's an OR command. So it's saying if display 1.1 and display 2.53, if either one of those are set, sorry, or not in, if 1.1 or 2.53 are set, then this control relay is going to latch and it's going to send a signal back to the knock center, the original application. So if we decode those, Jesse, what's 1.1 is alarm point 1?
Yeah, so 1.1 is a discrete alarm point 1. So if we saw a short on the first pair on the on this, which we see is labeled HVAC fail alarm or alarm fail.
So that's self-reported from the unit, right?
Yeah.
Yeah.
So basically, if the HVAC 1 has a discrete alarm output that's some kind of error state, we bring that over to the 66 block, and it's basically informing us, hey, I'm your far end unit. I can't run for whatever reason. Don't try to run me. Then that would come in and trigger this. Otherwise, a 253, so a total failure situation. Not exactly sure when total failure is triggered, but
I got this one. I remember this one. So this is if we have all of our string of D-wire sensors, one or more, that are acting as the guidepost for when to turn HVACs on and off. If we lose all those, we have the backup one on the board, right? But during testing, we clip that to see what would happen. Well, in the very first rev, it would record 0 degrees and kick on the heat.
yeah.
So the total failure indicates the absence of any temperature sensors, at which point we just shut down the units and we throw this huge alarm and we just tell you, hey, we don't know what's going on. We're not going to kick on HVACs. I can see this changing to, if we wanted maybe to be turn on the HVACs, I'd rather have it frigid than not. But at the moment, we just throw a huge alarm and we shut them down, as opposed to leaving the possibility of the heaters coming on, which is crazy.
Yeah, I guess if we ever identified a state where we needed to RMA a unit, that's a reasonable thing to do, rather than let sort of roll the dice on whatever on possibly a marginal board.
Yeah, that's a real struck by lightning kind of scenario to lose all the D-wire and lose the one on the board, but the code can handle it. That's what that's about.
And so beyond that, we've got some other things that we could hit out. There's the sensors here as well. Each of these sensors has thresholds as well for generating its own alarm data. Yeah, so you can set up notification on a sensor basis as well. So as you said, it sort of gets cool on one side of the building, hot on the other side of the building. If we ever ended up in a scenario where it was getting particularly hot around one sensor, that sensor itself can generate notifications. Hey, it's hot here. You might want to check out to see if the system is running as we would expect, or if something else is going on. Basically, the notification alarms can range from anything from kind of status kinds of ideas, like, hey, I just want to get notifications to understand when this kind of thing is happening to help debug more, to kind of more critical kinds of notifications where if we want need to take action based off of certain events, we can generate notifications out in that case as well. Let's see, beyond that, we got timers. This one doesn't have a lot of timers. The web refresh is basically how often we're refreshing numbers inside of monitor mode. This timed tick is useful as an alarm. Sometimes a monitoring master station is basically receives traps only and doesn't have any kind of hold process. In which case it's hard to tell if something's alive or dead unless something's going wrong with it. If everything's fine, it's just not generating notifications. So it's typically used as a heartbeat kind of idea. LCD cycle is a delay on cycling the LCD panel on the front. So there's a number of different status windows that it'll sort of cycle through. If we're not in any kind of configuration menu.
Jesse, do you have SNMP reporting here?
Yeah, I think that's going to be inside of notifications. We can see notifications has ability to send email, to send SNMP. In certain cases, there's spare relays that we can basically trigger a relay to be a contact closure and notify some kind of physical device on the other end that.
In this case, it's going to be SNMP, but via polling using gets, which I don't think you really need to set it up to respond to those, right? That's just native, whereas this is to set up some traps.
Yeah, if we're setting this up to be a SNMP responder, I'll have to review. I think that is enabled by default.
Yeah, we just need to have it switched on. I don't.
Yeah.
Okay.
And I've seen units that have an SNMP sort of front end for configuration of things like private and public community strings or.
Yeah, exactly. It's commonly in the system setup. Like there you go.
Here it is. It's inside the system. I'm looking right at it.
Yeah.
So, yeah. And sometimes it's broken out to a different tab. Yeah, so I mean,
is there somewhere there where you're setting the email server that it's using?
Yeah, so inside of your notifications, if we're going to trigger out an email, you should be able to basically give a SMTP server name or host name.
And as you can see, you get a warning if you change anything that requires a reboot, but that's about, 15 seconds, something like that.
The reboot isn't a lot of the things that it's used for. Sometimes there's a mission critical kind of thing that changes in part of the configuration that we got here. So the reboot required is just something that is going to show up to say, hey, you changed the configuration, you should probably reboot this. Some of the changes aren't necessarily reboot required significant. So making changes to those isn't going to trigger that message, but you can go through and finish all of your other provisioning. There's no need for us to sort of see this and immediately reboot. If we're provisioning the unit, we could provision everything that we need here, then do the reboot and have it come up afterwards.
Can you export and import the entire configuration?
Yes.
So if I set one of these up, with all my settings, which will be quite a bit, when I do the next one, I can just put that in it and change the IP address, or if it says DHCP, then we're good to go, or whatever. Yeah,
right here's where we're looking for that. So provision and system, or system, and there's a system control section. We could get a backup configuration. Hitting this config.bin is basically going to download a binary file that can be uploaded to any HVAC controller. We could just hit the upload config to the unit right here. That's going to upload the configuration back to the unit, and from there, basically only need to do some minor changes, possibly to Ethernet settings or enabling DHCP. One of the challenges.
Yeah, okay. Most of our sites are the same, so it'd be like change the name, change the IP, probably all,
Yeah.
right?
Exactly, and there would be some one of the things that I want to sort of caution a little bit there is that that the sensors are defined with a specific ROM ID that's unique to the sensor. So if you back up the configuration and you upload it to a different unit that has the same kinds of sensors attached to it, but not exactly the same sensors, then what you'll end up with is a number of sensors that aren't detected, and basically we'll need to go through and adjust the sensor IDs because that's a physical change that's happened from one unit to the next.
Is there somewhere that lists those? Like you see all the sensor IDs?
Yeah,
So you know what to put there. Okay.
It would either come up as a yellow sensor, which is detected and not configured in that spot. So it might be an issue of sort of moving up those configured sensors. And then we would see red sensors for these guys, which are units that are basically sensors that are attached to a different unit at that point. Each of the little sensor boxes that we ship out has the ROM ID printed on it. So if we needed to uniquely identify a sensor by looking at the sensor itself to know, hey, which one was this one? All of these sensor IDs look somewhat similar, but they're all different. It doesn't really tell us anything more than these ones are temperatures, this one is a humidity, if you know what to read on it. We do have those sort of printed on the sensor itself. So when those get shipped out to you, you would be able to verify the ROM IDs are sort of matching up with the physical ROM IDs on those on the sensors themselves. That said, if we ever had a scenario that was somewhat catastrophic and we needed to have the HVAC sensor RMA'd, if we had a backup available to us from that exact unit, and we had basically another HVAC controller, we could basically take the configuration from the previous one, upload it to the new unit, and then after that, it's just like remove the cables, plug it into the new into the new controller, and you're off to the races because everything's exactly the same, basically on a replacement unit.